Hello everyone and welcome to this launch week feature preview video. Today we're going to be talking about our newly released feature set, which we are calling Device Vitals. So what are Device Vitals? Well, put simply, Device Vitals are the three measures that we believe embedded development teams should be able to easily track across their entire fleet, both in development and particularly when you hit production. These three device vitals form the most common failure points for embedded devices. The three vitals are connectivity, battery life, and stability. Now, of course, not all three of those vitals will be relevant to every single embedded or IoT device, but likely a combination of at least two of them will be relevant to almost all embedded devices. And we believe you should have a good, consistent, and easy to use way to monitor those vitals across your entire fleet so that you can use the information to prioritize, to spot issues quickly, and to make highly informed decisions. And what we have done is built these device vitals into Memfault and into every single version of the new SDK. So on our Android SDK, version 4.13, our MCU SDK, version 1.5.0, and our Linux SDK, version 1.9.0, all of the metrics required to capture and compute these device vitals are built in. You need to configure them, and then you can start reporting data into Memfault right away. We've also developed a set of out-of-the-box visualizations for each of these device vitals, so you don't need to be a data scientist to start getting the insights. Pick the vitals you care about, select the visualizations that make most sense to you, and start understanding the performance and quality of your devices right away. So with that said, let's see what that actually looks like within Memfault. So I'm over in the Memfault platform and I am looking at our overview dashboard. So first up, I want to draw your attention to this software versions chart. So we released our new product on the February the 23rd, and we went live on our 1.0.0 software version. Then a little while later, we released an update on 1.1.0 software version. And we can see that was about 2 weeks ago, and now it's currently on 18% of my fleet. So I think it's time to investigate this software version and check and make sure that it's performing how I expect it to. In order to do that, I'm going to go over into another one of my dashboards here, which is my Device Vitals dashboard. Now you can see that at the moment, this Device Vitals dashboard that I'm looking at is filtered to my launch version, my 1.0.0 software version. And this is where I was keeping an eye on performance when we first went live. I can see that for the median device in my fleet, I get 73.5 hours of battery life, which is great, well above my stated minimums. I can see my Bluetooth sync success rate. This is our connectivity vital, or one of the options for our connectivity vital, is 97.73%. So a little room for improvement there, but still feel pretty good about that. And my stability is 100% for the median devices. So again, really great. Definitely couldn't ask for any better than that. What I'm going to do now is take a look at that new 1.1.0 software version and see how it's performing relative to the launch version. I've added that in now. I'm going to save that filter for everyone. So if anyone else in my team comes and looks at this dashboard, they will see the same software version filter set applied and look at the same information as what I'm viewing now. So first up, taking a look at our battery life vital, we can see that there's a slight regression here, which doesn't look too bad for the median device. But if I look at my percentiles, I can actually see a really serious regression in the lower fifth and first percentiles of my sample set here. So I can see I've got 28,000 samples from 127 devices, and the fifth percentile there is showing a pretty serious regression. So this is going to be something I'm going to investigate, but it does look like it's contained for now to a small set of samples. So I'm going to continue looking through the rest of my vitals. Now I'm looking at my connectivity vital, this BLE sync success rate, and I can see there's actually a big regression here as well. So we have a pretty significant drop down to 78% success rate. And the other thing I notice, if I look at this on my percentiles chart, I can actually see that we're seeing a regression across the board on all samples. We're seeing some kind of regression there. So this does not look like it's contained and looks like it's a problem for all devices on this software version. Similarly, if I look at my stability summary here, I see again a pretty significant regression in stability. This is for the median device. And once again, when I look at percentiles, I can see that there is a regression across the board here as well. So I'm going to start by investigating this. What I'm also looking for here is to see that perhaps there's a correlation between this drop in sync success rate and my drop in stability. So maybe something here causing a crash and also creating a disconnect scenario. What I'm going to do to start my investigation is I'm going to go and take a look at that lower percentile of devices. So I'm going to click through on this chart. And what I get here is a pre-filtered list of devices that have provided a sync success reading that is within the margins for that lower percentile. So that lower percentile was a 58.49% success rate to a 66.54% success rate for this 1.1.0 software version. I can see here are the devices that meet that criteria. I can see their individual sync success rates down the right-hand side here. And what I'm going to do is I'm just going to jump into the first one of these devices and see what's going on. So now in the device timeline, and I can see here on my timeline, all of the various different metrics that I'm collecting from my devices are displayed on this timeline, as well as any traces or reboots occurring on that device across the timeline. Now, I don't need to look at all of the metrics now. The one I really care about is my sync failure metric. This will tell me if that BLE sync success rate drop is related to anything. And straight away, I can see that there is very clearly a correlation with the spike in sync failures and a couple of asserts. So I have one assert here, which is a send next packet assert, and another, which is an NQ next packet assert that look like they're correlated. So to get us started, I'm actually going to jump straight into this first one. And I would like to point out a couple of things that I'm noticing when I look at this. So I'm in a trace of this issue. And what I see first off is that the software distribution for this specific issue is 100% on this 1.1.0 software version. What does that mean? Well, it means that I didn't catch this issue on the launch version, which probably suggests that this may well be something I've actually created on my new 1.1.0 software version. I'm also tracking my production batch ID here. This is a custom attribute, and I can see that this issue is broadly distributed across all production batches. So it doesn't look like this is a production related fault here. So I can pretty much rule that out. I see that one of my colleagues must be ahead of me. There's already a comment in this issue. I'm going to jump over and see what they've said. So they've said, Zephyr didn't set a reset reason here. Strange, it did for the assert in GAT NQ next packet. So this is the other assert that we were looking at on the timeline there. So I'm going to follow their link through and take a look at the trace for this second issue, the NQ next packet issue. Again, I'm seeing similar trends here. So this is all 100% on this 1.1.0 software version. And again, it's distributed across production batches. Doesn't look like there's anything particularly correlated there. Once again, my colleagues look like they're ahead of me. And I noticed a couple of things. So firstly, I noticed that we have, looking at the reset reason, which I can see in globals and statics. I'll take a look at this in a minute. We see that it's set to 0 times F2, 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 which indicates an allocation failure. I'll go and take a look at that in a minute. I can also see that a few days ago, we actually had a fix-up in version 1.1.1. So that's good. Looks like my team are already ahead of me, and I'll go and take a look at that in a second. But first, let me check out that reset reason. So I'm in the trace. I'm looking at the core dump from the device here, and I'm going to go and check out the reset reason. Here it is. I am going to take a look at that here. Clicking on it, I can see in memory there we have the F2, 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 F2. So yep, looks like that was indeed the problem. What I'm also going to do, just to try and confirm here that we have some correlation, is I'm going to go over into my issues, and I'm just going to take a look at the issues present on 1.1.0. So I can see a total of 5 issues here. And these 2 issues that I've just looked at are clearly the top issues. I have almost 600 traces each, and they're correlated on the same number of devices. Helpfully, one of my colleagues has actually already added a Bluetooth tag here, so that's great. We clearly agree there that this is the cause of the BLE sync success rate drop, and it also looks like this is going to be the cause of my stability drop with that number of traces for both of those issues. So what I'm going to do now is I'm actually going to go back over into my dashboard. My colleague mentioned we already had a fix up. So let's take a look at that fix in this newest version. So I'm going to add my 1.1.1 software version in here and take a look. So firstly, what do I see? Well, I see that battery life actually on my percentiles chart hasn't been fixed with this newest version. So that issue looks like it still persists. Again, though, pretty contained. I am going to take a look at that. It's just in my 5th percentile, but I am going to take a look. On my BLE sync success rate, this looks really good, pretty much back to normal there. On my stability summary for the median device, it looks great. It looks like we have resolved that issue, but I do still see an outlier here just on what looks like pretty much the first percentile. So this is something I'm going to dig into, but let me start by investigating this battery life problem that seems to be sticking around. So again, I'm going to click in there and I get presented with a list of devices that have that battery life reading. Clicking into this device now, what do I see? Well, if I look on the timeline, I'm actually going to switch over to my battery percent drop here, and I can see a couple of drops that seem to be correlated with another issue, a hard fault this time. I'm going to go into that hard fault and see what I can see. So the first thing I notice, if we're thinking about what we were just looking at on the other issues, for this issue, it's actually across two software versions. No surprise there. We're on 1.1.0 and 1.1.1. But the really interesting thing, when I'm thinking about my production batch attribute, I see that this issue is 100% correlated to a specific production batch. Now, what I already know is that we did actually have a bad production batch that was creating battery issues. So this is in fact a known fault in production. And I can actually just now suggest that my support team go ahead and return the devices, organize the returns with the customer for these devices on this production batch. Great. The final thing, though, that I would like to do to be absolutely sure that things are looking good in my latest version is I'm going to build a new dashboard. I'm going to build a release tracking dashboard, and I'm going to use one of my out-of-the-box device vitals dashboards. In this case, I'm going to pick stability to keep an eye on. I'm going to create that dashboard. And here you can see that I now have a bunch of pre-built cards and charts specifically tracking stability of my devices. I'm going to lock it down to that 1.1.1 software version because this is the one I really care about. And the other thing I'm actually going to do is I'm going to quickly add in a battery life chart too. I really want to confirm that this battery life problem is going to be resolved once we organize the returns for those customers. So I'm going to add a battery life device vitals card in here, and I'm going to get the overtime battery life visualization so that I can see that this actually does get better as we make those returns. I'm going to add that in here. I'm going to actually just make that a little bit bigger and drag it up in my dashboard so that I can see it right next to my stability cards. And there we go. I feel good now. I feel like I'm going to be on top of keeping track on this 1.1.1 version, and I should be able to really quickly spot if anything goes wrong. We hope you enjoyed this feature highlight video looking at some of our device vitals functionality. We're really excited about this. We think it adds some great additional capabilities for our customers looking to keep a close eye on the quality and performance of their devices without having to think too much about which metrics they should track, and without having to do any of the work themselves to visualize the data and get the insights. Memfold does it all for you. If you combine that with our exceptional debugging capabilities, we think that this is really going to speed up issue identification and investigation for embedded development teams, helping you build better quality products. If you want to find out how to get this up and running, there's a lot of information in our technical documentation, including integration guides for MCU, Android, and Linux. If you need any additional guidance, please reach out to the team and we'd be happy to help. Otherwise, we will see you in the next one. Thank you.